Hello everyone, my name is Kuo Shengzhen. Today I'm going to present my work, a constructive learning-based planning and control framework for symbolic manipulation of deformable linear objects. Although great success has been achieved in deformable object manipulation, most of them assume structure, configuration, and a fully specific goal. However, these assumptions are hard to satisfy in some symbolic real-world scenarios. In this paper, we provide a solution to this problem in the context of arranging a deformed linear object DLO to make it satisfy several geometric constraints, including robotic reachability and collision avoidance. Dual arms cannot grasp the ends of the DLO initially. Our goal is to change the state of the object to satisfy the geometric conditions. Here is the overview of the algorithm. Consists of state representation, subgoal planning, and goal conditional control. The state includes sequence keypoints of the DLO and the coordinate of obstacles. The action is defined as correspondence-based manipulation from the present state to the subgoal. The aim of the subgoal planner is to point out a promising direction toward the goal space instead of reaching the goal explicitly. We change the encoder in a constructive manner to encode the spatial-temporal relationship in the successful episode. The local controller is used to refine the configuration of the DLO based on the subgoal provided by the planner. We decouple the roles of chain arms as a leader and a follower, and both of them determine the pick and place sequence according to the action parameterization. Here is a typical example of a successful episode. Dual arms need to rearrange the object to modify its configuration in the world space. Note that this process is generally a long horizon process, consisting of multi-step pick and place sequence of dual arms. That's all, thank you.